In today's class, we are going to learn how to derive equation of uniformly accelerated motion. Before we proceed, what is meant by uniformly accelerated motion? The motion of an object accelerating uniformly is what we call uniformly accelerated motion. We can say that object as undergoes uniformly accelerated motion. Okay. Now there are three equations. Okay, there are three equations that we want to derive. So I want to pay attention. Okay, let's start with the first equation. The first equation is derived from acceleration. Okay, in our previous class we learned what is meant by acceleration. Acceleration tells us how fast the velocity of an object is changing with respect to time. Okay, so acceleration can be expressed mathematically as this. Acceleration is equals to change in velocity, that is the difference between the initial and final velocity of an object all over time. Are you paying attention? So acceleration is equals to v minus u, that is change in velocity all over time. You know, please, peradventure, if you have not part of our first class, please kindly check the link in the description of this video. Okay, so that you are going to understand. It's very important that you understand this basic concept. Okay, so acceleration is equals to v minus u, where v is the final velocity and u is the initial velocity of the object. So from this formula, we are going to make v the subject of the relation. Okay, now let's cross multiply. A multiplied by t, this one will multiply this, and this one will multiply v minus u. So I'm going to have v minus u is equals to at. Do you understand? Don't forget our aim. Our aim is to what? Make v the subject of the relation. So for this, I'm going to have v is equals to at plus u. Okay? Now we can rewrite this equation as this. V is equals to u plus at, because the sign before this at is what? Positive sign. Okay, and u also has a positive sign, so I can write u as this and at as this. So this equation is also the same thing as this equation. So the first equation of motion is what? V is equals to u plus at, that is v is equals to u plus at. Okay, now let's derive the second equation of motion. Okay, this is the first. Okay, now let us derive the second equation of motion. You see, the second equation of motion can be derived by finding the average speed of an object and then substituting the value of v as the first equation of motion. Please just pay attention, you are going to understand. Okay, let's say we have an object traveling with an initial velocity v, initial velocity v. Okay, initial velocity u, and final velocity v. Okay, we have an object traveling with initial velocity u and final velocity v. Now if you are taught to compute the average speed and average velocity of the object, average velocity I represent as, maybe I should just write it in full. Okay, average velocity is equals to v plus u all over 2. Do you understand? That is the sum of the initial final velocity and the initial velocity divided by 2. That is the average velocity. Do you understand? Now the average velocity is this. To compute the second equation of motion, all we need to do now is to substitute the value of v as u plus at. Don't forget that in the first equation of motion, we learned that v is equals to u plus at. Now, call this one, let me call this equation star. Okay, let's call this one equation star. Now, to compute the second equation of motion, all we need to do now is to substitute the value of v as what? U plus at. So for this, I'm going to have average velocity is equals to v is what? U plus at. So I'm going to have, instead of v in this place, I'm going to substitute it as what? U plus at. So I'm going to have u plus at plus u all over 2. Please, do you understand what I did? I've not done anything. All I did was that I substitute v as u plus at in this equation. Okay, now the next step is to collect like terms. Okay, the next step is to collect like terms. So I'm going to have average velocity is equals to, now we have u here, we have u here. I can sum this u and this u. So I'm going to have at plus 2u all over 2. Do you understand? Okay, now if I have, hello, please pay attention. If I have x plus y over 2, x plus y over 2 can be written as x over 2 plus y over 2. I'm very sure you understand. If I take the LCM, I'm still going to get this. Do you understand? So I just rewrite this because I'm going to explain something now. Okay, now we have gotten to this point. I can split this fraction. Okay, I'm going to have the average velocity is equals to at all over 2 plus 2u all over 2. Please, do you understand how I got this? You see, you know, I explained that this fraction can be split as this. So I split this fraction. I splitted this fraction 80 all over 2. If I take the LCM, I'm still going to get this. Okay. Now, these two can cancel these two. These two can cancel these two. So I'm going to have average velocity is equals to u plus at all over 2. Now, don't forget, in our previous class, we learned that velocity is distance, is the rate of change in distance of an object with time in a specified direction. Pay attention to that definition. Velocity is the rate at which the distance of an object is changing with respect to time in a specified direction. Do you understand? So, I'm going to substitute velocity as distance over time. So, I'm going to have s all over t is equals to u plus at all over, u plus at all over 2. The 2 is only the denominator of 80. Do you understand? So, for you to understand the advanced physics, these are the basic concepts that you have to understand first. Do you understand? Okay, so now, what I did here is that I changed this velocity to distance over time because velocity is the rate at which the distance of an object is changing with respect to time in a specified direction. Okay? Do you understand? If I didn't have direction, that would be speed. So I beseech you, kindly check the link in the description of this video to watch our previous class. That is our first class on these topics. So for this, I'm going to have s over t is equals to u plus at all over 2. Now, I want to make s the subject of the relation. Do you understand? So I'm going to multiply both sides by t. Okay? I'm going to multiply this by t, and I'm going to multiply this also by t. Do you understand? So t multiplied by s over t is what? St over t. So this t will cancel this t. Do you understand? So I'm left with what? S at the left hand side of this equation. Now we have u plus at all over 2 multiplied by t. That will be t multiplied by u is what? Ut. Okay? T multiplied by at is what? Plus at squared all over 2. The t will only multiply all this. I pay attention. So the final answer is s is equals to ut plus at squared all over 2. Now, this is the second equation of motion, but you can rewrite this. Okay? You can write it as s is equals to ut plus 1 over 2 at squared. It is also the same thing. Okay? because for this I'm going to 80 will be 80 squared will multiply the 1, which is what 80 squared, and this 2 will come down, which is what 2. Are you paying attention? So that is the second equation of motion. S is equals to ut plus 1 over 2 at squared. Okay, now let's proceed to the third equation of motion, derivation of the third equation of motion. The third equation of motion can be derived from the first and second equation of motion. Okay, just pay attention. Now, the first equation of motion is V is equals to U plus AT. Abi, this is the first equation of motion. Now, we are going to square both sides. Square both sides. I'm going to have V squared is equals to U plus AT squared. Okay, so I'm going to have V squared is equals to U plus AT multiplied by U plus AT. Do you understand? Okay, I just square both sides. I've not done anything. Okay, now let's go. V squared is equals to U multiplied by U. That is what? U squared. U multiplied by AT. Just like if you have something like this, A plus B. A plus B. The square of this, when you take the product of this and this, you are going to have A squared plus AB plus BA plus B squared. That is A squared plus 2AB plus B squared. Do you understand? That's what I'm doing here. So I've not done anything. Pay attention. U times U, U squared. U times AT, that is what? Plus UAT. Hello? Pay attention. A times A squared. A times B, AB. Do you understand? So U times U, U times U, U squared. U times AT, UAT. Okay? AT times U, that is what? Positive UAT. AT times AT, that is what? AT, that is plus AT squared. Please, do you understand how I got to this place? If you don't understand, reverse the video and watch it again. Okay? Let's go. For this, I'm going to have V squared is equals to U squared plus UAT plus UAT. That is what? 2UAT. 2UAT. Plus, now, if you have AB squared, that is what? AB times AB. Abi, that is what? A squared, B squared. Do you understand? That is A times A squared. B times B squared. A squared, B squared. Do you understand? Okay, now we have AT squared. That will be what? A squared, T squared. A squared, T squared. Now, I want to pay attention here, okay? This is where the second equation of motion comes in. The first step here now is that I'm going to factorize 2A. Okay? V squared is equals to U squared plus, I'm going to factorize 2A from this and this. Maybe I should just write it out, okay? I want to factorize 2A, 2UAT plus A squared T squared. I want to factorize 2A out of this expression. Now, 2A into bracket, pay attention, that will be ut plus, you see, if I factorize 2A, out of this 2UAT, I write 2A out of this bracket, so I have only ut at this side now. Okay, this is, I've already factorized this. I've factorized 2A out of this term. Now let's go to the second one. We have A squared and T squared. If I want to factorize, I can only factorize A out of this expression. So I'm going to have A T squared all over 2. By the time I take the product of these 2A, by the time I open this bracket by this 2A, I'm still going to have something like this. Do you understand? Please, this is very simple. Just pay attention. I want to factorize 2A out of this. Now, I've already written 2A out of this bracket. Now, for the first term now, if I multiply 2a times 2ut, I'm going to have 2uat. Is that not it? That's it. But for the second one, to make this, by the time I take the product of this 2a and this a t squared over 2, I'm still going to have a squared t squared. Is that not it? If not, you can try it. 2a multiplied by 2a multiplied by a t squared. These two will cancel these two, abi, and a will multiply a. I'm going to have a squared, and this t squared is there. That's t squared. So that means if I factorize this, I'm going to have this. Do you understand? Okay, now let's substitute plus 2a into bracket ut plus at squared all over 2. Please, do you understand it to this point? Okay, now don't forget, from the second equation of motion, ut plus half at squared, let me rewrite it. This can be written as v squared is equals to u squared plus 2a into bracket ut plus 1 over 2 at squared. Don't forget, we've learned this now when we are deriving the second equation of motion. Okay, now from the second equation of motion, ut plus 1 over 2 at squared is what? S. So I can substitute this as the value of s. So I'm going to have v squared is equals to u squared plus 2a. Instead of ut plus 1 over 2 at squared, I'm going to have s. Do you understand? So this is 2as. This is the third equation of motion. Okay, that is v squared is equals to u squared plus 2as. So that is the we've been able to derive the first, second, and third equation of uniformly accelerated motion. Now, having derived the three equations of motion, you can see we have the first, second, and third. The parameters here, v is velocity, u is initial velocity, v is final velocity, okay? U is initial velocity, a is acceleration, and t is time, okay? S is the distance. Do you understand? Okay, these are the parameters that we have in this equation. Now, before we solve any question, I want you to note 3 points, okay? I want to write these 3 points down. When an object starts from rest, that's the first point, okay? When an object moves or accelerates from rest, the initial velocity of the object is 0, okay? That's the first point. I'm going to explain, just pay attention, okay? Now, the second point is that when a body comes to rest or stops, its final velocity v is equals to 0. And the third point is that when a body's velocity is constant, that is when a body is moving with a constant velocity, the acceleration is 0. Now let's start with the first point. We are told that when an object moves or accelerates from rest, the initial velocity is 0. What's velocity? Velocity tells us how far the rate of distance traveled by a body with respect to time in a specified direction. Okay, now if the object is at rest, therefore there is no initial velocity, the object is not moving. You understand? Now let's talk about the second point. When a body comes to rest after undergoing motion, okay, that is when the body comes to rest after undergoing motion, is final velocity v is 0. Do you understand? You know, let's say an object is moving before, then it comes to rest. The final velocity v will be equals to what? 0. Okay? Now let's talk about the third point. When a body's velocity is constant, the acceleration of that body is 0. Now look at this. Acceleration is equals to v minus u over t. Do you understand? Now, if the velocity of an object is constant, that is the initial velocity is the same as the final velocity. Let's say a body is moving with a velocity of 4 meters per second. Okay, the body is moving with a velocity of 4 meters per second. Now, that means the u, if the acceleration of that, if the velocity of that object is constant, that means u is what? 4 meters per second. And v will be what? 4 meters per second. Now, if we have the same velocity and the same initial velocity and the same final velocity, that means acceleration is equal to 4 minus 4 over t. I don't want to know the what your t is. This is equals to 0, regardless of the value of the t, because the numerator is what? 0. 4 minus 4 is 0. So when the velocity of an object is constant, acceleration is 0. Okay? Please note as 3 points. Okay? And it's very, very important that you note this, because you are going to use it to solve question on this on equation of motion. We are going to use it. Okay, so I want to note it down. Now let's have some work example on what we have learned so far. To watch the next class, kindly check the description of this video. We are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.